Welcome to EMI603 Superlab. It's using new information to make a prediction based on a model. If you're watching this video at home, you should have the paper out in front of you. That's EMI603 so that you can follow along with us. We're going to get started by going through the background information. EMI603 is a skill commonly connected to the conflicting viewpoint passages. Those are the ones with the dueling scientists. But you can actually find it anywhere on the test. The skill requires you to first outline a scientist idea that's being presented. This is what we call a model. A model is a scientist's way of summarizing how a system works based on some evidence that they've collected. A question will then present you with some new information. You'll then need to see how that new information would fit into the scientist's model. All right, so a couple of things. This is usually conflicting viewpoint passages, but not always. Today's an example where it's not a conflicting viewpoint passage. All right. It's also the term model. We're just using it. It's essentially a scientist's idea of how something works. All right, so they'll give you an idea of how something should work. They'll give you some new information, and you try to see how it would fit into their current model. All right, let's take a look at an example of what this would look like. It says, below is an example of a scientist's model about how to tell if a frog is poisonous or not. While the information is made up, none of this is actually real. It is a good example of what you might read on an ACT. All right, so if you come across a frog that has a certain number of spots, don't feel like it's safe to lick it or that it's dangerous. You can determine how poisonous a frog is based on the number of spots it has on its back. Frogs with no spots or fewer than 5 spots are not poisonous. Frogs with 6 to 10 spots are poisonous to kill small animals, but not human. Frogs with more than 10 spots are poisonous enough to kill a human. All right, again, this is all fake. It's totally made up. All right, but what you can then do, this is one scientist's idea about poisonous frogs. You then be able to answer a question like a new species of frog is discovered with 8 spots. What could you predict about this frog? So what you just have to do is look back to the other scientist's model. His idea is that anywhere from 0 to 5 is safe, anywhere from 6 to 10 is sort of dangerous, and anywhere more than 10, you should run away from the frog. All right, in this case, a new species of frog has 8 spots. What can we predict about it? All right, what do we think we could predict about this frog? Yeah, it'll kill a small animal, but it probably won't kill you. All right, it's got 8 spots, so it's going to be somewhere in that 6 to 10 range. So it'd be able to kill a small animal, but not a human. All right, so it's using some new information and trying to make it fit with somebody's current model. All right. The guided practice section is now going to take us through the passage that we're going to need to understand in order to get through this skill sheet. So let's get started by reading the passage. If we are following along, bless you, if you are following along, what you should have in your hand right now is an implement of writing. As we go through the passage, you should circle, highlight, or underline, however your preferred method of marking is, any words that are tricky or confusing that you think could get in your way of understanding what the passage is talking about. We'll then identify those together so that we're all on the same page with the vocab. All right, let's get started with the passage. The reactivity series of metals is a chemical series produced by arranging the metals in an increasing order of their ease of reaction with reagents such as oxygen, water, and acid. An example of such an arrangement, starting with the most reactive, is potassium, sodium, calcium, magnesium, tin, copper, silver, gold. This arrangement aids the understanding of the properties of metals, helps to explain differences between them, and enables predictions to be made about a metal's behavior. It also allows predictions of the relative stability of the compounds formed by an element. The more reactive the metal, the more stable its compounds are likely to be. Table 1 shows the results of reactions of various metals with oxygen, water, and acid. The position of a metal in the periodic table helps chemists determine its overall reactivity. The position determines the reactions of the metal with various reagents, the displacement of one metal from its compound by another metal, and the method of extraction of a metal from its ore. All right. That one was a mouthful. There's a lot of chemical vocab in there, which you may be familiar with or may not be. Let's start to take a look at some of these words. Does anyone have a word that we want to circle, highlight, or underline that may be getting in our way or confusing? Reagents. Nice. Reagents. Reagents. Second line? Bottom. All right, another one. Or. Good. Other words. We have reagents and ores. Really, there's the only two words in here that are confusing. Last time we went through this, there was quite a few. Ease, nice. The ease of which. All right. Also, maybe think of some words that somebody watching from home might be confused about. Maybe that you'd recommend. Stability, that's a good one. Relative stability. All right. And any other ones? Displacement, good. That was one that I was thinking of. Nice. Any other ones? Okay. Let's start taking a look through the vocab here. Remember, with the vocab, there's 3 ways to figure out what a word means. First and easiest way is it's defined for us in the passage. Second way, we figure it out from background knowledge or context clues. Third way, we look it up. We don't have a dictionary on the ACT, so we try to avoid that one. Let's get started with the first one, ease. Is it defined for us in the passage? No, it is not. All right, but you have heard a word that is similar to that before. What does that word ease mean? Easy, yeah. All right, so it's in arranging the metals and increasing order of their ease of reaction. So it's essentially how easy do they react with something. All right, how easily is it to get this thing to react with something? All right, of reaction with reagents such as oxygen, water, and acid. What is a reagent? This is a chemistry term. It's not defined for us here, so we're going to have to use some background knowledge that we remember from chemistry. What is a reagent? It is a chemical. All right, and what's specific about a reagent? Nice. All right, you can use it to test the reactivity of other things. Reagents are things that you would mix and they would react in some way, shape, or form. All right, so reagents are chemicals that we can use to test reactivity. All right, they essentially they undergo reactions with other materials. Oh. All right, next one, stability. Again, not defined for us, but we can probably use either the root of the word or background knowledge to figure this one out. Stable, we see the root here, stable. All right, now if a chemical is stable, what does that mean? So like it's different than like if a table is stable. All right, if a table is stable or a building is stable, it's not going to fall over. But what do we mean by a chemical that is stable?
Like it's not, there was no reaction.
Nice. Yeah, if it were just sitting there, it wouldn't likely react with anything. So a really stable chemical is one that won't react very easily with things. Whereas very unstable chemicals, they'll react with anything. All right, and they can actually be pretty destructive or harmful. All right, so this is stable. Next one, displacement. Again, not defined for us here. What do we mean by displacement? All right, so we see this word here, placement, that we recommend, that we not recommend, that we recognize. All right, and what happens if you put a dis in front of a word? What does it mean? Yeah, so what does that prefix dis mean? Yeah, either out or opposite, some might even call it. So it's like the opposite of placing something would be essentially removing something. So if you displace something, you remove it. So people after Hurricane Katrina were displaced from their houses because of all the damage. They had to be removed and put somewhere else. All right, in this case, the displacement of one metal from its compound is like the removal of one metal and replacement for another metal. So like there's things like NaCl is salt. All right, sodium can actually be displaced by another substance called potassium. And so you can actually usually it's potassium displacing the sodium, but like the Na can be kicked out by a K that comes in here, which will then be cassia. All right, so the sodium was actually displaced from this and like removed from the reaction, and the K took its spot. All right, that's what we mean by displacement. Last but not least, what about ore? O-R-E. Again, it's not defined for us. All right, but we know it has something to do with a method of extraction of a metal from its ore. What is an ore?
Like the metal's base.
Yeah, where would you expect to find ore? Yeah, this is like what they dig underground. So if you go, like if you own a gold mine, there's not like bricks of gold that are growing from trees underground. All right, what happens is you get like this chunk of rock that just has tiny amounts of gold actually in it. You then usually have to break down the ore. You either melt it, and so it'll separate based on its densities, and you just draw off the pure gold. All right, ore is like an unpurified form of a substance, and it's usually what you dig up from underground. All right, so all of you who own gold mines or platinum mines, you are very familiar with ore because that's what you're actually pulling out of the ground. All right, and then you purify it into its substance. Okay, any questions before we move on? All right, so then here's my question for you. What in the world is this passage talking about? If we've defined all of the vocab words that could get in our way, what is this passage talking about? Nice. That's actually the crux of this whole passage is we're talking about chemicals that react with other things, and then how likely they are to do that is what this whole passage is talking about. So what we can then do is move on to this table below, and this is kind of the results of their experiment. All right. They essentially took copper and they tried to react it with oxygen, water, and acid, and watched what happened. They did the same thing with calcium, reacted it with oxygen, water, and acid, and tried to see if it worked. And these are the results that they got. Yes, sir.
Would putting them in order from most reactive to least reactive, would that help you like match viscosity viewpoints?
That would be incredibly important. And it's actually why, if you look at the, oh, that's going to be question 2. All right. Hold that thought for 1 second. All right. Let's first jump to the first question then on the very bottom, no, I'm sorry, in the back of the paper. The question 1, asks you the first step is to figure out what the model is actually saying. And so we kind of had it summarized for us a second ago. And so you answer the following questions to summarize the model. The reactivity series of metals determines how likely an element is to react with reagents, such as, what are the 3 reagents that we're testing in this case? Nice. Water, acid, and oxygen. Perfect. All right. Now the next question is going to get to what the last student question was. Is it beneficial to put them in order? Totally beneficial to put them in order. Because the whole model, what they're going to start to ask you then is they're going to try to have you like hypothesize different things about if this thing is more reactive than that thing, what would it react with? And so you need to know the order for that to happen. So question 2 says in table 2, which is a table that's added on the back, this was not actually part of the passage. This is a way for you to organize your thoughts. List the 8 elements given in the passage in order from most reactive to least reactive. Now, I always suggest reading the hints. They're written on there for a purpose. Because remember, the order given in the passage starts with the most reactive and ends with the least reactive. So you don't have to go back and figure it out. Because if you notice, it's in the 3rd sentence. It says an example of such an arrangement starting with the most reactive, and then it lists all of them in order. So what you want to do right now is taking a look at your table. All right, table 2, the most reactive one should go on the far left or on the far right? Left, because it says most reactive on this side to least reactive on this side. So we'll start with the most reactive one. What is the most reactive element we're looking at here? Potassium. Good, because it's the first one in our list. So you'll fill in potassium. All right. What's the next one on the list that would go next to it? Sodium. All right. We already had potassium, and now we're at sodium. So we'll fill in sodium next to it. All right, now you'll keep going through, and what you want to do right now is pause the video and finish filling in this table. It should only take you a few seconds. When you're done filling in the table, press play to go through the answers to make sure you have them in order. All right, at this point, you should be pressing play if you're ready to go through the order. If you eventually went through, you should end up with a table that looks like, oh, I did it separately. Nope. That looks like this one right here. It should start with potassium, then have sodium, then calcium, then magnesium, then tin, then copper, then silver, then gold. All right, so our most reactive substance is potassium, and our least reactive substance should then be gold. All right. The next thing we need to look at then is now that we have this organizational structure in place, we can start using it. So what's the benefit of putting them in order? Well, now we can actually map out which things are reacting with which other things. All right, so question 3 says in table 2, put a check mark in the react H2O row for any elements that react with water. And the hint here is that any substance that does not say no reaction reacts with water. So there's tons of different types of reactions. You could put an acid on something and have it make tiny little bubbles, and that's considered a reaction. You could put acid on something and it blows up half the building. That's also a reaction. All right, any sort of chemical exchange is considered a reaction in this case. All right, so if we start and we're looking at the water one first, all right, we're going to go through and look for the ones that do react. Does copper react with water? No. If you trace copper over to water, you see it says no reaction. So under where it says copper and then water, we're not going to put anything there because it doesn't react. All right, what about calcium? Does it react? Yeah, it fizzes slightly, so that does mean react. So we'll go calcium, water, and we'll put a little check mark or an X there. All right. There's 2 more that react with water. Which other 2 react with water? Potassium and sodium. Boop, 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 boop. Now, it's kind of interesting. What do you notice about the way the table is organized in terms of where all the check marks are? Right. So all of your X's are on which side? The left side. Because the most reactive things should react with things. All right. Things that are not very reactive, like silver and gold, they don't react with water, and so we shouldn't expect any X's over there. All right. Question 4 then says to fill it in also with the oxygen and fill it in with the acid sections. So what you want to do right now is just like we did for water, you want to fill in the rest of the table for the oxygen row and the acid row now. If you're watching this at home, you should press pause and press play when your whole table is filled. If you are pressing play at this point, that means you've finished filling in your table and you're ready to take a look at the answers. The final completed version of our organized table should look like so. All right, it should look like this. You should have all the elements listed across the top, all right, in order of reactivity, and your X's should look exactly like the X's on here. Now, the reason we do something like this is to really get a handle on this kind of question, all right? You're going to see chemistry questions on maybe things that you're not familiar with. You would never make this table on an ACT, all right? You wouldn't have time to do this. But remember, we're learning skills that are hopefully going to help us not just on a test, but also through life. So if you can take a passage like that and organize it into a table like this, you'll find much more success with anything that you do in science. Because you can learn something now by looking at this. Can anybody kind of learn anything by taking a look at this table? Would anybody like to share one thing that you could figure out by looking at this table? Nice. Potassium, sodium, and calcium, they'll react with everything. All right? And it makes sense because they're also on the most reactive side. All right? And they'll react with whatever. It doesn't matter. They don't care. Nice. Gold, very unreactive. So unreactive, in fact, it does not react with any of our 3 reagents that we used in this experiment. All right, those are 2 great things to start to pull out. Gold will not oxidize. Pure gold will not. Now, this is mildly different. Some of you may be thinking like, oh, well, I have gold jewelry that does oxidize. A lot of your gold jewelry is actually copper. All right, when you talk about carats of jewelry, so 18 karat gold and 24 karat gold, the lower the purity of the gold, the lower the K value, the more pure gold is in it. The problem is that pure gold is very squishy and soft. Like pure gold is like very hard Play-Doh. So if you had a ring or jewelry that was made out of pure gold and you wore it as a ring, it would be bent in half by the end of the day. And so that's why they mix gold with copper, because it makes the gold harder. But the problem with that is that then it's not as pure gold anymore. So copper does react with oxygen, and that's why like your gold jewelry will tarnish over time, because it's actually the copper in the gold jewelry that's doing the reacting, which is kind of the more you know, the more you grow. Science, 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 science. Okay. There's a couple other things you can figure out now too. Like look for patterns. If you react with water, what else do you react with? What else do you react with? And what else? Acid. You notice that the things that react with water also have to react with acid and oxygen. All right. And so you can kind of get an idea of stubbornness to react. Like certain reactants are harder to react with than other ones. And this is that idea of stability. Like which one of our three reactants, water, acid, or oxygen, is the easiest thing to react with? Oxygen. You notice that oxygen reacts with almost everything. And if you react with oxygen, you can also react with other things. All right? Like if you react with water, you have to react with acid and oxygen. If you react with acid, you have to react with water. I'm sorry, you have to react with oxygen, but you don't necessarily have to react with water. And so this is where this table really starts to come into play, when you start to realize how these kind of play off one another. Is that, okay, well, if I know that, like if I came up with a new substance called bioncantanium, and I said bioncantanium reacts with water, what else do you know about bioncantanium? What else does it react with? Acid and oxygen. Because if it reacts with water, that means it has to also react with acid and oxygen, because those are easier to react with than water is. And this is where the table really starts to become useful in terms of these questions. Because you can make statements like, okay, well, if something is less reactive than tin, so you move this way more from tin, would it react with water? No, because anything to the right of tin is not ever going to have an X in this water row. And that's one of the ways that we can tell this kind of information. All right, and that's why this table really starts to come into play, so that when you start to get into questions, like the questions on the skill sheet, like number 5, an experiment uncovered that iron was more reactive than tin, but less reactive than magnesium. Which of these things do you know would be true? All right, so if it's more reactive than tin, is it to the left of tin or to the right of tin? Left. So we know it's got to be somewhere that way. But it's less reactive than magnesium. So does it have to be the left of magnesium or the right of magnesium? The right. So we know it's got to be somewhere then in here. What do we know for sure then about iron? We know for sure that it would not react with water. Perfect. Because if it's less reactive than magnesium, and magnesium doesn't react with water, there's no way that iron could react with water. All right. Now, A is wrong, because we know it would have to react with oxygen, because both tin and magnesium react with it. So if it's in between those, it's got to react with oxygen. All right. It would not react with water. Well, that's the opposite of what we just said. I'm sorry, that's the right answer. It would not react with acid. We don't know that for sure, because magnesium does react with acid. Tin doesn't react with acid. So we don't know if it would react with acid or not. All right. What you want to do right now is you want to start to go through the next few questions. You want to go through 6, 7, and 8. with your groups. If you're doing this at home, try them on your own. When you're ready to start going through the answers, press play and we'll go through them together. If you are pressing play at this point, that means you're ready to go through the answers. One thing that you want to start to become more comfortable with is you want to start to ignore this table. Because on the ACT and on the skill sheets, you are not going to see this table. This is something we made to help ourselves organize the data. You want to start to be able to use this data in the same way. All right, you kind of have to reorganize it in your mind. So if we take a look, we see mercury would be placed between copper and silver in the reactivity series. If mercury was exposed to oxygen, what would happen? All right, so in this case, we're looking for copper and silver. All right, the question says, if it were exposed to oxygen, what would happen? All right, what we see is that copper, that would have had a check mark in it, reacts with oxygen. Silver also reacts with oxygen. If we know that mercury would be between copper and silver, we also know that it should oxidize. It should form an oxide on heating. All right, now again, we can do that without this little table. We can just use the big one for that. Researchers recently discovered that zinc fizzes slightly when exposed to acid, but does not react with water. So now this is giving it the information to us a different way. All right, and so if it fizzes slightly when exposed to acid, but does not react with water, this is where using the table and starting to see which one of these is the most reactive starts to come into play. All right. If it reacts with acid, it also has to react with what? Oxygen, yeah. If we know it reacts with acid, we also then know, even if we didn't have this, even if we were just looking at the big table, everything that reacts with acid also reacts with oxygen. So, if it reacts with acid, it should react with oxygen, which is B. All right. We don't know. Actually, it tells us here that it does not react with water, so we can get rid of A. All right. We should know that C isn't true because oxygen is the most reactive thing on there. And then it doesn't say anything about melting point, so that one's just trying to distract you. Last but not least, an engineer is designing a new submarine. This is kind of the application of this question. Why are they doing this experiment? Which of the following materials should the engineer avoid based on the data from this experiment? If you're in a submarine, what are you going to be exposed to a lot of? Water. Meaning that you do not want to explode when you're exposed to what? Water. If you made a submarine out of potassium, that would be very, very bad. All right? That's called a torpedo, not a submarine. All right? So you don't want to react with water. All right? Taking a look at these then, we look with reaction with water. Which one does not react with water? What are our options? Magnesium. Magnesium has no reaction. Sodium, it would fizz. We wouldn't want our submarine to fizz. Copper, no reaction. And silver, no reaction. So then which one should he avoid or she avoid, the submarine maker? Sodium, because you would not want to make a submarine that fizzes underwater. All right. Okay. At this point, we're going to get started taking some quizzes. If you're ready to take this quiz at home, good luck to you. If you are still confused about any of these, please rewind the video at this point and play back any part that you are confused about before you move on to the quiz. If you're ready for the quiz, good luck.